Welcome to the Crazy Hat Chemist. Here we go. Basic stoichiometry problem. Still, this is the 7th problem here in this subset of stoichiometry and dimensional analysis. So let's get moving on it. Boom! Moles and gases. Okay, 1 mole of any gas at STP, that's standard temperature and pressure, is equal to 22.414 liters. Okay, the derivation of this, and we have already done we will do the gas unit, so there's that video on gases already online, so check it out. So the gas unit will tell us the derivation of this, and that's PV equals nRT. We're solving for the volume of 1 mole. So we're plugging in 1 mole under STP conditions, and we get what? 22.414 liters, and this is how this comes about. Okay, so make sure you look at that gas video as well, so you know what's going on. So, here's our 7th problem. What is the volume in liters of 96.2 grams of oxygen gas at STP conditions? That key part there is at STP. Otherwise, if it doesn't say STP, we're going to have to go to the gas unit and figure out what to do there. But the first thing that we need to do is get the formula for oxygen gas. And oxygen gas is one of these, and that is one of the diatomics. It's one of the 7. So here is the formula for oxygen gas. And then we're going to have our flow chart. Here's our flow chart. What are we starting off with? 96.2 grams, and that's a mass. So what do we want to go to? And that is a volume, and that's right down there. There is no direct route. You can't just go from mass to volume. You have to go first from mass to moles, and we're going to use the molar mass for oxygen gas. So that's one thing you want to do. And then from moles, then we're going to go to volume. Because it's at STP conditions, we can use the concept of 1 mole equals 22.414 liters. So I want you to pause the video really quickly, set up that monorail like you should know how to do, and then restart the video. So here we go. Bam! So we got the molar mass here of 32 grams for oxygen. That cancels out the units for grams. Okay, and then I'm going to use that concept that we just learned here, and that is 1 mole is equal to 22.414 liters of any gas. Not just oxygen gas, but any gas. And it can only be a gas. This does not apply to solids, liquids, aqueous, no way, no how, only gases. So the moles here are going to cancel out. Now I'm going to plug, I need to figure out my significant figures. So there's 3 significant figures for my starting number, infinite for the moles, and for the 22.414 liters, there's 5 significant figures. The molar mass for oxygen has 4 significant figures, and then 1 for the significant figures. For the mole, 1 mole is an infinite number of significant figures. I'm going to get a number in my calculator, and then I'm going to round this to 3 significant figures, which is the least number of significant figures in this problem. So I'm looking at that 8 for rounding. Okay, now I'm looking at that 8 for rounding. That's 5 or greater, so I'm going to add 1 to the preceding digit. That 3 becomes a 4. Now I have number, units, and a formula like I do all the time. Okay? So, the question is, why do you end every problem with a number, units, and a formula? Well, this is from one of my students because there's been enough said about that. Okay? All right, fantastic. Let's keep on going. There's a little bit more I want to discuss. Okay, so notes on the flow chart. So we've been using this flow chart now for 7 problems. Okay, but I want to point out a couple of things that many students have a difficult time with. Okay, and so I'm going to use something that you should be holding near and dear to your heart and you should be familiar with. And that is $1. So if let's say you had $1, I'm going to replace that $1 and make that my 1 mole. So I got $1 is equal to my 1 mole. Okay, I could convert that dollar into dimes. How many dimes would it be? It would be 10 dimes. That's like going from dollars to dimes. That's like going from moles to mass. Now I'm going to go from dollars to molecules, and that's like going from dollars to quarters. Okay, and then from quarters, I can go to something else, and that would be nickels, and that's just like going from molecules to atoms. And that dollar can also go to pennies, and that's like going to volume. So that's my flow chart, but with money for U.S. currency, if you are familiar with that. So keep that in mind. I'm going to highlight 2 specific areas that students also have problems with. What is the value in front of the mole when you are in this green section? The value for the mole is a 1. What's the value for the molecules? It's Avogadro's number. So it's 1 mole and Avogadro's number. Then when you are in this yellow section, what's the number in front of the molecule? It's a 1, just like the flow chart shows you right there. And then it's a counting number of atoms using the formula. So the molecules, the number in front of the molecules can either be a 1 or Avogadro's number. It depends on where you are in this flow chart. So pay particular attention to this. Hopefully that will help you with some other issues. And then example, take a look at that example with the money. Okay. I hear you went out to dinner over the weekend. Yes, I did, baby. How was your meal? Molicious. Yum. Where'd you go? It was on the moon. That's where the restaurant was. So would you recommend it? The food was great, but the restaurant had no atmosphere. So I'm the Crazy Hat Chemist, and that was the last subset of videos dealing with basic stoichiometry problems. Okay? I will see you next time for a percent composition from the formula. So I look forward to that. See you then.